So this question has been asked tons of times in so many interviews, Amazon, Google, Microsoft, Flipkart, so many companies. It's good to know about this question. So the question says that we have been given two words, word 1 and word 2. They're nothing, they're just two strings of different sizes. Now what we want to do is we want to find the minimum number of operations required to convert word 1 into word 2. What is the minimum number of operations required to convert word 1 into word 2? Is the question complete or is it missing something according to you? So it should talk about what are the different kinds of operations it supports. Yeah, valid question. So what are the different kinds of operations it supports? So there are 3 operations that it supports. Now listen to them very carefully. The better you listen, the better you will be able to think. So the first kind of operation that you can do is you can insert a character. Keep it in your mind that you have to change word 1 to become word 2. So word 1 is your source word. You can tamper word 1. You don't have to tamper word 2. So you have to tamper, you have to change word 1 so that it becomes word 2. Now, what kind of changes are allowed? So the first kind of change that is allowed in word 1 is that you can insert a character in word 1. And it means you can literally insert any character at any position. So if your word 1 is, let's say, apple, then you can insert B over here, you can insert D over here, you can insert Q over here, you can insert N over here, you can insert any character anywhere. That is the first kind of operation which is allowed. The second kind of operation that is allowed is you can delete a character. And now again, from your word 1, you can delete any character of your choice. So you can choose to delete this P, or you can choose to delete that E. You can delete any character from anywhere. And the third operation is that is allowed is you can replace a character. Now again, this is very open-ended. You can replace any character with anything. So you can replace this L by Q. You can replace this A by M. So these are the 3 operations which are allowed. And now you have to think and tell me that how many minimum operations do I need to convert word 1 into word 2? Okay, so let's take an example. If your word 1 is horse and your word 2 is Ross, what do you think should be our answer? What is the minimum number of operations required to convert word 1 to word 2, horse to Ross? Okay, so let us take a look and understand. So what is our source word? What is the source word which we have to change? It is horse. So let's take horse and let's play with it. So our source word is horse. And what if I first replace H by R? If I replace this H by R, we will get roars. Right? Let's do the next operation. What according to you should be the next optimal operation? Maybe now we can remove R. Which R? This R. If I remove this R, we will get rose. Now I think we are just 1 inch away. What should be one more operation that we should do? We should remove this E. If we remove this E, what we will get will be Ross. So you landed from horse to Ross by just performing 1, 2, and 3 operations. So your answer is going to be 3. I'm sure that you can't do this transformation from horse to Ross in lesser than 3 steps. You have to perform at least 3 steps. Does that make sense to all? Yes or no? Yeah. So this thing here, 3, is called as edit distance of horse and Ross. Edit distance. It is also called as Levenshtein distance. No need to remember, just for you to know it. So what is edit distance? Edit distance is simply a number that denotes the degree of similarity between 2 words. So let's say there are two words which are very, very similar. If they are very similar, will their edit distance be very high or very low? It'll be very low. But if there are two words which are very different, then the edit distance will be very high. And this edit distance is a very practical thing. It is not just a theoretical dynamic programming question. It is something which is practically used by so many applications, by so many softwares. How many of you have experienced spelling correction being done on maybe WhatsApp or being done on Microsoft Word or Google Doc? Have you experienced that happening? Auto correction, you can call that auto correction. So what usually happens is that whenever you write a word and WhatsApp feels that the WhatsApp does not have that word in its dictionary, then it suggests you those words which are very similar to it. And what is the meaning of similar? So it computes the edit distance of all the words with it and then tries to find that which words are having very small edit distance, and then it shows them off to you. So edit distance is very, very important thing. Another thing, so those of you who would have ordered something from Amazon, when you write your address, when you mention your address, if there are some spelling mistakes in your address, let's say you are writing Delhi and there is some slight spelling mistake in Delhi, then Amazon software can detect that, yeah, the edit distance between what you wrote and what Amazon has is very low. So probably you meant to write Delhi, so it will auto correct it. So these are some very, very practical applications of edit distance. It is a very important thing. Cool. So now let's come to the important thing. We want to write an algorithm which computes edit distance of two words. So yeah, you will see that if you have paid attention to me explaining longest common subsequence, then this thing will look like a cakewalk for you. Very, very easy. So don't need to worry if you have paid attention there. Trust that it is going to be easy. So let's say there are two words, word 1 and word 2. And now just look at the board, stop thinking. There are two words, word 1 and word 2. Now, let's say your word 1 ends with A and word 2 ends with A. This is your ith and this is your jth character. We are starting from the last characters. So yeah, let's look here for now. Let's say there are two words, word 1 and word 2, and you're scanning them from the end. If the last characters are matching, if word 1 of I is matching with word 2 of J, will it contribute to the edit distance? If the last characters are matching, will it contribute to the edit distance? Will you want to do anything to this A? Will you want to convert this A into something? Will you want to delete it? Or will you want to insert something after it? Anything like that? No. Anything like that will be absolute nonsense, because these characters are doing no harm. They are already matching. Because they are already matching, so let them match. And focus your attention on the remaining part of word 1 and the remaining part of word 2. So I can say that if word 1 of I and word 2 of J, which is the last characters of the two words, if they are matching, then the edit distance of ij is nothing but the same as edit distance of I minus 1, j minus 1. So again, this is a very, very obvious thing, nothing special about it. Another way in which you can realize this thing is, let's say there is a word 1 and there is a word 2. Your word 1 is ABC and your word 2 is APQ. So tell me, what is the edit distance between ABC and APQ? How many changes do you need to do in ABC to convert it to APQ? Two changes. The first change is you can convert B to P and you can convert C to Q. Now, if I introduce a character R here, another character R here, does the edit distance get changed? No. So if the last characters are same, the edit distance of this and that is going to be the same as the edit distance of this and that. And this is exactly what I have explained here and written it there. So this was the case when the last characters matched. What if the last characters do not match? So let's say your word 1 ends with B This is your ith character. And your word 2 ends with A. This is your jth character. So if the last characters do not match, if this is B, but that is A, will you want to leave this B as it is? Is it a correct thing to leave it as it is? No, we need to take some action. We need to act. How many element of choices do we have? We have 3 elements of choices. The first choice could have been to insert a character. What character would you want to insert in word 1, if at all you want to insert? What character? You'd want to insert A. Because if you insert an A right after this B, then that A will start matching with this A. The moment this A starts to match with this A, then you can now easily focus on finding the edit distance of remaining part of word 1 with remaining part of word 2. The first choice that we had was to insert. If we insert, that means we are doing 1 unit of operation. And after doing that 1 unit of operation, what just happened? The character that you inserted got matched with jth character of W2. So now your J will go back, but your I will still stay there. You understand this point? Because this B has not been matched with anything. So your I will still stay there, but your J will move back by 1 unit. So what kind of transition will happen? ED of I comma J minus 1. This is what happens in case of you inserting a character in W1 to match the last character of W2. So this is the transition corresponding to insert. Does that make sense to all? Okay. What could have been the other choice? The other choice could have been to delete a character. So let's do it all over again. Your word 1 ending with B, your word 2 ending with A. This is your ith and that is your jth character. If at all you want to delete some character, which character you would want to delete? You'd want to delete B, because if you delete this B, it may happen that there was an A before it that kind of got matched with this A, or there was some other A before this B that at some point of time got matched with it. So the second choice that you have is delete. Corresponding to delete, what will happen? Because you delete this character, so your I will move back, but your J will still stay there. So in this case, your I moves, but your J still stays there. What is the final operation that you can do? Replace. So let's say there was B here. If you want to replace this B with something, what will you want to replace it with? You'd want to replace it with A. The moment you do that, both these characters get matched. And now you focus on the remaining part of word 1 and remaining part of word 2, in which I will also change and J will also change. So in this case, corresponding to replace, it will be 1 plus ED of I minus 1, J minus 1. So when the last characters of the 2 words did not match, then we had these 3 options. But what should be our actual answer? We are interested in the minimum number of operations. So whatever is the minimum of these 3 things, that is going to be the value of ED of IJ. So isn't it easy? It's extremely easy if you stick to the concepts. So what you have to do is that you have some strings, and let's say you are scanning those strings from backwards, then there can be only 2 possibilities. Either the current characters match or they do not match. If they match, think what should be your transition. And if they do not match, then think how many elements of choice you have. Corresponding to those elements of choice, you will see how your I and J, they kind of change. Are you able to understand this idea? Are you able to understand how to think? So I'm not interested in you just being able to understand this question. It's the thought process which is important. If that is being ignited inside you, then that is of significance to me. Nothing else matters. There should be some meaning of EDIJ. What is the meaning of EDIJ? The meaning of EDIJ is I denotes the part of first word from 0 to I, and J denotes the part of word 2 from 0 to J. Whatever is the edit distance of this prefix of word 1 and that prefix of word 2, that is ED of IJ. Okay, if you understand it, now we are almost ready to write the recursive code. But before writing the recursive code, we need to be clear about the termination conditions. Guys, do you see one thing here, that again, your I and J are always being reduced only. So even if this condition is true, your I and J are being decremented. And even if the last characters did not match, your I and J, they are being decremented only. So eventually it can happen that either your I becomes -1 or your J becomes -1. So if your I becomes -1, what kind of word 1 does it denote? It denotes an empty word 1, right? Now tell me one thing, if your word 1 is empty and your word 2 is something like A, B, C, D, what will be the edit distance? How will it be 0? How can you do 0 operations to this and convert it to A, B, C, D? Is that possible? 4. So if the first word is empty, you have to insert all the characters of this 1 by 1, 1 by 1, 1 by 1 here. So if the first word is empty, the answer is going to be equal to the length of second word. Do you get that? Similarly, what will happen if your J is -1? If your second word is empty and your first word is, let's say, ABCD, what will you do? You have no choice but to delete all the characters from here. So it means that if second word is empty, which is if your J is -1, then you have to return the length of your first word. As simple as that. Do you get it? So this is what your termination condition is. Now, what will be the length of second word? Sorry, what will be the length of your first word? If the last index is I, what will be the length? Will it be I or will it be I plus 1? It will be I plus 1 because indexing starts from 0. So we can say that if J is -1, return I plus 1, which denotes the length of first word. Similarly, if your I is -1, if your word 1 is empty, then return J plus 1, which denotes the length of second word. So that is your simple termination condition. So we are just talking about termination condition. So whenever you have to think about termination condition, just think how your I and J are changing. So you can see that your I and J are always reducing only. So eventually it can happen that your I becomes -1. So if your I becomes -1, that means that the first word is empty. If the first word is empty and you want to convert it into word 2, you have no choice but to add all these characters 1 by 1 here. If your I is -1, you just return J plus 1 because J plus 1 at that time will denote the length of second word. Similarly, if your J is -1 and you want to convert word 1 into an empty word, you have to delete all the characters. So you will have to return I plus 1, which denotes the length of your word 1 at that stage. Cool. So we have our termination condition. We have our recurrence relation. So can you write the recursive code? I'll write a recursive code called as get edit distance, which is taking I and J and returns an integer denoting the edit distance. So if I is -1, return J plus 1 as discussed. And if J is -1, return I plus 1 as discussed. Otherwise, what to do? So the first thing you will do is you will compare the last characters of the two words. So if word 1 I matches word 2 J, what will you do? You will simply say that, hey, return the edit distance of remaining parts, right? If this is the case. Okay, otherwise, what will you do? Otherwise, there are elements of choice. So that means you're supposed to be making these 3 calls. And after making these 3 calls, whatever is the minimum value of them, that you will return. So you can say, hey, otherwise, I'll return minimum of the three things, and you can put those three things as it is over here. You can put those three things as it is over here. That's it, job done. So this is your logic. So there will be overlapping subproblems because you can see that two of the calls here, I comma j minus 1 and I minus 1 comma j, are just like LCS calls, isn't it? So if in LCS you got repetitions, here also you will get repetition for sure. Correct? So there will be repetition. So what to do? Memoize. The first step is to decide what is the dimension of this problem. What is the dimension of this problem? 2 dimension. We need I and j. So we need an answer array of 2 dimension. Now what will be the size of first dimension? The size of first dimension depends upon how many different values I can have. How many different values I can have? I denotes the length of word 1. So if the length of word 1 is m, then I will vary from 0 to m minus 1. So this can be of size m. With the same logic, this can be of size n, and everything can be initialized to null, null, null initially. So this is the initialization that can be performed. Okay, in this case, you can also initialize everything to minus 1, minus 1, minus 1. It is up to you because, see, initialize them to something which for sure is crap, which for sure is garbage, because we know that edit distance can never be a negative quantity. So if answer of ij is negative, that means it's a garbage value. It's not been solved. So you can initialize them to null. You can initialize them to minus infinity, negative thing, anything. That's up to you. It does not really matter. Okay, now only things that remains over here is memoization checks. Can you put your memoization checks? Super easy. So after termination condition here, you can check if answer of ij is not equals to null, then you will simply return answer of ij. Otherwise, you will make the call and you will store that inside answer ij. Same thing needs to be done in the other scenario as well. You will solve for it and you will store it inside answer ij. And finally, you will just return answer ij. Job done. Do you observe that there is a very, very similar pattern which is being used across all the problems of DP? So the only thing that you need to do is you need to practice with this pattern. So you have this set idea inside your brain. Now you need to work with this idea on some problems. So again, like if you have your if you have an ongoing subscription on Renaissance, you have a lot of ample of homeworks based on the applications of this idea. So like once you learned LIS, LCS, you found that river wala question to be very exciting. Similarly, once you learned this, you will find its application based questions that are there to be very exciting, and you'll be able to map the thought process. You'll be able to apply the thought process, and then you'll be able to retain it for a very long amount of time. Then this will just become a nature of you, a nature with which you can think for a given dynamic programming question. Anyways, let's talk about the space complexity. The space complexity is going to be m into n because we have declared answer array of size m into n. What about time complexity? What were the steps to figure out time complexity? The first step was to find how many different problems we are solving. So how many different problems we are solving? M into n. And in order to solve a problem, how much work we are doing? So even if you're in this case, you're just doing one assignment operation. In the other case, you're finding minimum of maybe 3 things, doing 3 additions. You're doing constant work for each problem. And there are m into n problems. The total work will be nothing but m into n.